what are the types of cracks which will form? It can form on the surface of the cast product, so which you can see. So, we call them surface crack. These are basically related to uneven shell growth. I have mentioned that sticker type of grains do not indicate uneven shell growth, but when you have depression type of characteristic, that means for around 0.1% carbon, the so called petrolatic grades or 304 stainless steel, we have uneven shell growth along the mold. There is a large area of the periphery of the mold. So, along this periphery the shell growth is non-uniform for depression type of grades. So, because of that there is a possibility of surface crack formation. Now, what are the directions of the surface cracks? They can be longitudinal, they can be at the mid face, they can be near the corner locations. I will indicate in figures how do they look like, but basically I am trying to here tell you what are the types of cracks, what are the locations, the direction of cracks. Location and direction both are important. Location means whether at the surface or the interior, direction means whether they are in the longitudinal direction, that means along the direction of the casting, or in the transverse direction at the perpendicular to the casting direction, or at corner location. It can be at the corner location, it can be at other locations also. So, we will see those cracks. So, the longitudinal cracks it can be at mid face, it can be near corner locations, on billet surface, bloom surface or slab surface, and all around for round section. In round section you do not have a corner, so it can be at any location on round section. In fact, round section casting is very difficult. Round section it is very difficult to have uniform shell growth. So, we have to be very careful when we are casting a round, otherwise there will be a lot of surface crack formation at different locations all around the round sections. Now, this longitudinal cracks sometimes or most of the time they coincide with the longitudinal depression. I have told you there is a possibility of longitudinal depression in depression grades because of uneven shell formation. So, if you have longitudinal depression, normally you find beneath those depressions there will be cracks. So, longitudinal cracks they can coincide with longitudinal depression. Now, you can have transverse cracks as well. Where do the transverse cracks from? Transverse cracks means the orientation of the cracks are perpendicular to the casting direction. So, they are perpendicular to the longitudinal direction. So, the transverse cracks primarily are related to deep oscillation marks and transverse depressions. I have told you that normal oscillation marks do not constitute a defect in cast product. Since you have oscillation during continuous casting, you will always have transverse oscillation marks. These oscillation marks are at transverse direction, that means perpendicular to the casting direction. So, these oscillation marks, if they are not deep, they do not cause any problem, they do not constitute any defect. But if you have a deep oscillation marks, it depends on what I had mentioned earlier. It depends on what are the type of oscillation you are giving, what is the amplitude of oscillation, what is the frequency of oscillation. I have mentioned this negative strip time, the concept of negative strip time. If the negative strip time is more, you have very deep oscillation marks. So, your objective will always be to control deep oscillation marks by controlling negative strip time. So, particularly for the depression type of grades where the tendency will be to have deep oscillation marks, you can control it by manipulating the oscillation characteristics like amplitude, like frequency. These are the important issues. So, transverse cracks primarily located at deep oscillation marks and transverse depressions. Now, these are surface cracks which you can see on the surface of the cast product. that is bloom, round, billet, or slab. But there are certain cracks inside the casting which you cannot see. How you can see those cracks? If you take a transverse section, then you can see those cracks. Sometimes some cracks will be visible if you take a transverse section. On the surface it is very easy to see, just like that when the cast product has come out of the caster after it gets cooled, or even during, if the cracks are quite large in dimension, you can see it when during the casting stage itself, and the final stage of casting, when the cast product is horizontal, when it is moving horizontally, then on the top surface you can see if there is a cast, there are cracks or there are depressions, and there will be these defects even at the bottom surface also, even on the narrow face also, because what you are seeing is only the top surface. So on the surface you can see the defects, but internal cracks or internal defects you cannot see normally on the cast product. So what do we have to do? We have to take a transverse section, whether it is XY section or it is a ZY section, any transverse section. It can be longitudinal transverse section, it can be widthwise transverse section. So whatever transverse section, that means either you take it width is to thickness, that ratio, that surface, or LT surface, or width WT surface, or the LT surface. Then there can be two cross sections. So you have to see those cross sections, then only these internal cracks will be revealed. So this is related to interdendritic. Why do they form? They are related to interdendritic hot tears. I have mentioned to you that around solidification end temperature there is a brittle temperature region. So during the interdendritic, that means intercolumnar regions which are relatively weak, so we call them hot tears. There will be formation of crack in those interdendritic intercolumnar regions, so we call them internal crack. Why do they form? If there is strain in the solidifying shell, the strain, if it is limited within some limits, that means it is less than the critical value, then the crack formation can be controlled. But if the strain generation rather is relatively high, the magnitude is relatively high, then you can have, which is above the critical limit, you can have cracks, internal cracks in the hot tears we call it, some people call it, in the interdendritic region at relatively high temperature they are forming. Now where do they form? Then again they can form, that means we call it midway, that means at the mid section you can form. They can form at the diagonal region, where the solidification fronts are meeting, that is a relatively weak area. So intercolumnar area, there it can form. It can form the triple point, again it is a weak area. Triple point basically means what? Different solidification fronts are meeting, that is called a triple point area. Then it can form at the central line, this is again a weak area. I will discuss in details what is the problem for central line defects. It can be crack, it can be segregation, because what is central line? This area is solidified at the end, that means this area is relatively rich in solute because of segregation. There will be segregation, I have mentioned, in all steel whenever solidification is taking place, because there are alloying elements in steel, and all alloying elements, all solutes will segregate, will cause segregation. But some elements will segregate more, like phosphorus and sulfur. Some other elements like manganese, silicon will segregate less. But nevertheless there is segregation for all alloying elements. And which area will have more segregation? The area of casting which is solidified at the last, because that liquid which solidified at the last became relatively more rich in all alloying elements. whether it is carbon, whether it is manganese, whether it is silicon, whether it is phosphorus, whether it is sulfur, that particular area will have more enrichment. So, we have centerline problems. There may be crack, there may be segregation. So, internal crack at the center line is a problem, because of the poor cast structure we can have crack at the center line. If the superheat is more, what is going to happen? If the superheat is more, columnar zone extends almost towards the center portion of the casting. If the superheat is less, there will be equiax zone in the central region of the casting. That means the area of the cast which is solidifying at the last normally should have equiax zone if the superheat is less, say about 10 or 20. But if the superheat is more, say 40 or 45 or 50, then you may have columnar zones extending from the surface of the cast product till the central region. That means it is throughout columnar structure, there is no equiax zone. So, if you have such a structure, if you have only columnar zone till the central area, you might have cracks, because that area is relatively poor in every respect. The strength is less, because of high segregation. So, segregation will be there, strength is also less, toughness is less. So, that particular region will have cracks, will have lot of segregation. So, centerline segregation will be there. So, I have mentioned about the location and direction of cracks. These cracks are after all forming because when the strain in the solid shell exceeds the critical limit. So, that is what we have to remember. If during continuous casting we have less amount of strain on the solid shell, probability of crack formation is less, possibility of formation of crack will be low. So, relatively the cast product will have good quality, it will be free from cracks. But if the strain can come, as I have told you, because of many factors. Whenever there is solidification, towards the end of solidification is a brittle temperature region. So, whenever any strain is there, the shell is getting bent, there will be strain. During shrinkage there will be strain, the ferrostatic pressure will create some strain. So, different types of strain, possibility of different type of strain is actually there during continuous casting. So, if the strains can be controlled within limits, then you can have a caster or cast product which have less cracks or no cracks at all. So, the whole idea is to control the strain formation, to control them within limits. It should not exceed the critical limit, then only we will have less cracks. Now, let us see what are the type of cracks which can form. This is very important. I will try to indicate what are the surface defects, internal defects for billet, bloom and round, and also for the slab which is relatively flat. So, just see what are the types of cracks. This is you can call it a billet or a bloom, and if it is a round section, then you have we call it a round. But anyway, let us see what are the types of possibilities of location of cracks. See, one, we have told it, these are longitudinal mid face cracks. What is the location of the crack? It is longitudinal because in the casting direction in the long direction, so it is longitudinal. But the location is mid face. This is one face, this we call it a broad face. So, here you have at the mid face region, at the mid region of the face, if you have a crack, we call it, and the longitudinal crack or longitudinal mid face crack. Now, you can have other locations also, so they are called longitudinal surface cracks, these two. It can be quite long, it can be even small, the dimensions can be different, but from the location, if they are not in the mid-phase region, we call it normal surface cracks. If it is the mid-phase region, we call it mid-phase crack. Now, this 3, look at the 3, what is there? This 3. If there is a crack along this corner, this is one corner, this is one corner, so this is also one corner. This crack formation has taken place along the corner. So, direction is longitudinal, so 3 is basically longitudinal corner crack. So, this is direction is longitudinal, but along the longitudinal corner. So, from the location you can tell it is longitudinal corner crack. Now, look at this crack 4. This is not exactly at the corner, but it is slightly off from the corner. So, we call it longitudinal off corner crack. Again the direction is longitudinal, but we call it this one and this one, we call it longitudinal off corner crack. Now, look at 5. What are the direction of these cracks? If 1 was longitudinal, 5 is transverse, because it is at perpendicular at about 90 degree to the longitudinal direction. This is the transverse direction. This is the direction of the casting, the long direction, that is called the long direction. So, this is the transverse direction. So, 5 we call it transverse surface cracks, surface but at transverse direction. So, we call it transverse surface cracks. Look at 6, these cracks. These are transverse direction. This 3 was a longitudinal corner crack, but what about those cracks at 6? These are transverse cracks, but at the corner. So, we call them transverse corner cracks. So, depending on the location, depending on the direction, we call them longitudinal or transverse or mid face. If we are at middle of the face, we call them mid face. If it is random, we may call it normal surface cracks, and if we are at the corner region, it can be direction is long in the longitudinal direction, longitudinal corner crack. If the direction is transverse, we call them at the corner region, we call them transverse corner crack. This location 4, look at location 4 here and here, they are off corner crack, not exactly at the corner, but slightly off from the corner, but not mid phase. Mid phase would have been here like 5. So, this 4 is called longitudinal off corner crack, and there may be some fine cracks anywhere on the surface. So, we call them simply fine cracks. This we call it fine cracks on the surface. Sometimes these cracks are associated with what I had told, brittleness at intergranular brittleness for austenite grain boundaries. If you analyze these areas, some of these fine cracks may be found around the prior austenite grain boundaries, and the austenite grain boundaries then because of nitride formation, whether aluminum nitride, vanadium nitride, or other types, other nitride, microalloy nitrides. So, they can cause such type of fine cracks. So, I have tried to explain on the surface of billets, bloom and rounds what are the type of different cracks. Now, let us see what are the internal defects, internal cracks or other defects in billet, bloom and round. Earlier I have shown surface defects. Now, let us concentrate on internal defects. What are internal defects? Defects which you cannot see on the surface, you can see only at a cross section. So, we have to take a cross section, whether this cross section or this longitudinal section, then only you can see those defects. Now, let us see what are those defects. So, 1 is basically what? You are seeing only the section of the crack, you are not seeing the whole crack. So, the crack may extend like this. So, when you are at the interface, at the cross section, you are seeing only trace of it. So, this is longitudinal corner crack. This is near the corner area, this is one corner, and this indicates if you cut, if you take another section somewhere slightly away from it, if you find a trace, similar trace, that means it is extending from here to here. You are seeing only the trace of it in the longitudinal section, in the transverse section. So, this is called longitudinal corner crack. Why longitudinal? Because it is along this direction. So, longitudinal and near the corner, so longitudinal corner crack. But this is internal crack, longitudinal corner crack, internal crack, not the surface crack. Surface crack, had it been longitudinal corner crack at the surface, you would have found it here on the surface, but it is internal crack, not at the surface, slightly interior. But the location is interior, that is why it is called internal crack, but it is longitudinal in direction. So, near the corner, so longitudinal corner, internal crack. Now, look at another crack, say here, it is 2, it is called longitudinal off corner crack. This is the corner, this was the corner, so 1 was near the corner, so it is called it corner crack. 2 is slightly away from the corner, so we call it off corner crack, and we are seeing only the trace of it. So, basically these cracks will start here, will maybe going to here, this side. So, if you take a section, another section parallel to this, if you find the trace of it, then that means that crack has extended from here to there, that area. So, this is the problem of our internal cracks. You have to look at several sections, several transverse sections. Then if you just look at one section, maybe you may miss the internal cracks. You have to see several sections, several cross sections, then only you will know whether cracks or defects are there at internal locations. Now, look at this crack, there are 3 locations. What are these cracks? We call them halfway internal crack. All these are internal cracks only, it is not on the surface. So, internal crack, but halfway, that means from the surface, it is not at the center even, so it is halfway between the surface and the center. I am talking of the cross section, this is the center of the section, this is the surface. So, these are halfway, either this or this. Why do they form? They will normally form at the intercolumnar weak areas, hot tear you can call it, but the strain was such, because of the strain, maybe during bending or during unbending, there might be stress formation, too much of stress in certain areas, location of the shell, solidifying shell. So, there cracks will generate. So, the strain amplitude value was more than the critical level. So, that is why crack formation has taken place, hot tear has taken place. So, we call it halfway crack because of its location. Now, look at 4, it is we call it a spider crack. Spider crack can be at the surface as well as can be internal, but the location, it is oriented in different small in dimension and oriented in different directions. So, it is called a spider, sort of it is not a particular orientation is not there, that is why it is called a spider, like a spider. So, it is an internal crack, but spider, we call it a spider crack because of the orientation, different orientation it has. Then we may have a diagonal crack, look at 5. What is this? This is a diagonal of the at the section of the cast. Why it can form? I have mentioned the solidification front is starting from here, solidification front is starting from this side. So, at the diagonal there is a mismatch of the solidification front. Columnar grains are starting from here and extending, columnar grains are starting from here and extending. So, at the diagonal the 2 columns are possibly meeting. So, this is a defect area. So, we call them if the crack formation is at the diagonal area, we call them diagonal crack, diagonal internal crack. Now, what is not mentioned here is another crack here. You look at here, this is the central region of the cast. You may have a crack here. So, if you see the cross section, you may have a crack at the central region, you may have a crack on this section. So, this is called a central crack or central defect. That means, if you have too much of segregation, then also it will look like a crack. So, you may have a crack, you may have a segregation at the central region. So, it is called a central crack or central defect. So, what are the types of internal defects I have talked about? Longitudinal corner crack, one. Longitudinal cracks, you are only seeing the trace on one section. If you take another section, you will find the trace of it if it exceeds. So, it is longitudinal direction means it is exceeding in direction, longitudinal direction, but internal, not at the surface. So, it is longitudinal corner crack, internal corner crack. Now, we can have longitudinal off corner crack, is 2. I have told you, not exactly at the corner region, slightly away from the corner, but it is longitudinal. If you take another section, you will find trace of it. So, it is longitudinal off corner crack. Then we have mentioned about the halfway crack, this 3, this is halfway crack, halfway crack. So, halfway means halfway between the surface and the center we may have cracks. So, it is called halfway cracks. Then we may have a spider crack, not any particular orientation, different type of orientation. So, it is called a spider crack, but internal crack. We may have diagonal internal crack at the diagonal areas, around the diagonals where the solidification fronts are meeting. So, it is a weak area in the cast product. So, because the orientation is different here, orientation is particular orientation, cast track columns, columnar zone is increasing from here to here, and in this around this phase it will increase this way. So, they are meeting in the diagonal area. So, this is a defect area. So, you can have a crack at these defect areas. So, diagonal internal crack. Then I have mentioned you can have a crack at the central location. So, you call it a centerline crack or central crack or central segregation or centerline segregation. So, these are the internal cracks. Earlier I have mentioned about the surface cracks. Now, I am talking of the internal defects in billet, bloom or round.